So after our Tuesday evening class, we've had some questions about exactly how do you go about producing the tree diagram that we mentioned in relation to activity 2.1 building blocks. So I thought I would take a few minutes and show you the resources related to that and show you how you can begin developing that tree diagram, and also maybe give you some tips about how you can do this with your students. So right now I've got the teacher edition of our design and modeling course pulled up here, and I've already navigated to activity 2.1 building blocks. Before you teach this with your students, you definitely want to take a look at it. But as you go down through the teacher notes, you're going to see you got a section on generate concepts down here, which is where the tree diagram information is located. And if you read through it, it does a pretty good job of explaining what a tree diagram is in the way of a mathematical model, what it's for, and how you can use it. So they give us an example to start with of coin flips. So if you read the description, you see what's going on, and you can see here they developed their tree diagram at this point based on that situation. And then after that, they actually get into the criteria and constraints related to the puzzle cube design and have that listed for us, at least the parts that relate to number of cubes in the puzzle parts and that sort of thing. And then there is a discussion about the tree diagram itself. And you can see at this point they actually have given us an example of what that tree diagram looks like for the puzzle design. And then there is an explanation of how it's developed. And this one actually shows you the correct and complete options that lead to the correct puzzle there. So you've got some good resources in your teacher notes, but you need to be sure and access those and go through them at this point. So what I thought I'd do is actually stop the recording at this point and switch over and show you how I would actually develop this tree diagram with a class. So let's pause for just a second as I switch over. So this is the sheet that I like to use with my students to help develop the tree diagram and kind of show you what goes on here. Usually what I will do is I'll project this onto my whiteboard and I'll work the tree diagram on the board while the students are working it on a sheet, same sheet that I've given them. And one of the things that I notice is, when you get about 2/3 of the way through here, the students have caught on to what's going on with the tree diagram. You really don't have to walk them through step by step anymore once they see how to develop that. So we'll take a look here and go through at least part of how this is put together. So tree diagrams are built depending upon the criteria and constraints for the situation that you're dealing with. So for this one, we have 5 puzzle pieces. So actually 5 levels in the tree diagram. First piece, second piece, the third piece is at this level, fourth piece is here, fifth piece is this last row down here, right? So as we begin this one, from our criteria, we know that the first 2 pieces in the puzzle have to have 6 cubes. That's one of our constraints that we're given there. So I go ahead and I put 6 in here and 6 in here. And one of the things that I do as I'm working through here is I want to keep a running count of how many wooden cubes I've used, because I know that a correct puzzle will have 27 cubes in it. So 6 plus 6 is 12. So through these 2 pieces I've accounted for 12 cubes. Now, after those are done, at the third piece can have 4, 5, or 6 cubes in it. So 4, 5, 6 cubes. Alright, and it'll be the same thing at the fourth piece. 4, 5, or 6 cubes for that pathway. Same thing here. Same thing coming off this third piece right here, 4, 5, or 6. And And for the fifth, it'll be the exact same thing. So for every path down through there, when you get to this level, the options are going to be 4, 5, or 6 cubes for the last piece. Takes a little bit to get all those put in there. Alright, so I've got all of the numbers for cubes placed in the tree diagram at this point. So what I want to do is continue working from that second puzzle piece up there on down through the tree. So I've got 6 and 6 cubes in these two pieces. And if I come down and I look at this piece, this option down here for the third piece with 4 cubes in it, 12 plus this 4 would be a total of 16 cubes that are accounted for. So I've not gotten to 27 yet, so I know I'm going to keep working, right? And if I go 12 plus this 5 at this point, that'll be 17. 12 plus 6 here on this option would be 18. Alright, so through 3 pieces, I've not used up all the cubes that I need for this puzzle, so I know I'm going to keep going. So I'm going to go right on to the fourth piece. So if I follow this last path down here from 6, 6, 4, and the fourth piece has 4 cubes in it, 16 plus 4 is 20. Well, I'm not to 27 yet, so I'm going to keep going. 16 plus 5 is 21. 16 plus 6 is 22. So everything down that path at this point is still an option for my puzzle. So let's come down this one, 6, 6, 5, and with 17 cubes accounted for, plus 4 would be 21. 17 plus 5 is 22. 17 plus 6 is 23. So down this path, everything is still an option. Nothing has been eliminated. So the last one up here, 6, 6, 6 plus 4 at this point, 18 plus 4 would be 22. 18 plus 5 is 23. 18 plus 6 is 24. So through 4 puzzle pieces, every single option is still viable at this point. Right? I haven't eliminated anything yet because I'm looking for anything that is not 27 cubes through 5 pieces to be something that I would eliminate. Alright, so let's go and start again. Let's go through this first path, 6, 6, 4, 4. If I add 4 more, 20 at that point, plus 4 is 24. So this one does not work. So what I do is I go ahead and cross it out at that point. That one's not viable. 20 plus 5 is 25. That one's not viable. That one goes away. 20 plus 6 is not enough. Cross that out. So everything down this path, 6, 6, 4, 4, and all the options that go with that are not possibilities for my puzzle. Alright, so let's go 6, 6, 4, 5 and see what we get. 21 total plus 4 is 25. That one doesn't work. 21 plus 5 is 26. That one does not work. 21 plus 6 is 27. So this one works. So the puzzle combination is 6, 6, 4, 5, 6. And what I have my students do is come over and add that to their sheet. I've got an option that is 6, 6, 4, 5, 6. So there is a puzzle combination out there with those numbers of cubes in the parts that will work. My tree diagram is telling me that. Alright, so let's go on to this one here. 6, 6, 4, 6. That's 22. Plus 4 is 26. That one does not work. 22 plus 5 is 27. That one does work. So that is 6, 6, 4, 6, 5. 6, 6, 4, 6, 5. Now, if you're looking closely, you're going to say, well, that's the same combination that we just had in one before that, but it's in a different order. So, in my mind, these are, if you're thinking about a family, these would be like cousins. They're related to each other. They're very similar, but there's something different about that particular combination. They are 2 distinct puzzle combinations there. And by this point, you're going to find your students have pretty much caught on how this process goes, and then they can go ahead and they can finish it out for themselves here. So I'm going to finish this branch right here. 22 plus this 6 is not viable. All right, so you're going to have them go through that process there, continuing through the rest of the tree diagram, and you're going to find that they're going to find several combinations of 6, 6, 6, 4, 5. You know, there's several versions of that. Now I want to show you a little different one in here. If we come down the center, 6, 6, 5, 5, and we follow that branch, we've accounted for 22 cubes. 22 plus 4 for the last piece, well, that's 26. That doesn't work. 22 plus 5 is 27. That one works. All right, so that's a 6, 6, 5, 5, 5 possible combination. So I'm going to put that down here. 6, 6, 5, 5, 5. Little bit different combination right there, and you'll find that there's only one of those in this puzzle. So, you know, at this point, I would have my students go ahead and finish it out and find all the possible combinations. They're going to find something like 6 or 7 versions of this first one, 6, 6, 6, 4, 5, and then they've got one version, 6, 6, 5, 5, 5. And what they have done when they finish that is actually looked at what possible combinations will work based on the tree diagram, based on the criteria, based on the constraints. And they've also eliminated quite a few combinations that don't work based on those criterion constraints. So the tree diagram has narrowed them down from something like 20 some possible combinations down to this small handful that will actually work, and gets them to a place where they can actually focus on the possibilities that are viable, instead of having to look at the whole set, many of which would not work for them. So this is actually how you go about creating a tree diagram, and a little bit about how it's helpful and what it does for you and for the students as you're going through activity 2.1 and designing the puzzle cube. Hope this helps, and let me know if you have questions.